Oh, bear with me 1 second, please. Okay, I'm back. All right. Welcome back, everybody. We got one more person joining us. Okay, well, let us continue. Any questions, comments, concerns? You may have noticed I did send an email concerning the exam, which was originally set for Tuesday. I moved it over to Thursday. Okay, that give you a little more time to work on it because obviously we're not even close. I'm going to finish up close to finishing chapters. I'll finish up chapter 2 today, jump into 1, actually go into some other aspects about chapter 3, I should say. And then they actually finish that up on Tuesday, chapter 3, and give you plenty of time to get ready for the exam on the following Thursday. Okay. Now, the first 2 weeks or so, it gets a little hectic, a lot of stuff we throw at you, and that's why I moved the dates over for homework and so forth. I mentioned that if you needed another attempt and you've done all the attempts, for example, for the homework, feel free to shoot me an email, say I need a third one. I have no problems with that. But once we get stable, everything should fall into play, and we're going to be doing like 1 or 2 chapters a week. So things will balance out. Okay, be less hectic. All right, well, let me continue with the let's see, where were we on slide 19 of chapter 2. Okay, what we were talking about here, we're getting ready to, is talking about significant figures. We actually finished talking about rounding numbers. Okay, and so here the number that we're going to round is either going to remain the same or be kicked up to the next value, depending on what the immediate value of its neighbor is, okay, of the immediate neighbor, not the number that's 3 or 4 neighbors down the road. We don't care about that, just the immediate neighbor. And if its value is less than 5, then that number that we're going to round stays the same. The number doesn't drop, okay? It's either going to stay the same or go up. And if the immediate neighbor, its value is greater than or equal to 5, then that number that we're going to round goes to the next value, okay? The important aspect about rounding is this: we don't want to change the magnitude, the value of the number that you begin with. So anytime you're rounding numbers, take a look at the digit. What is my value? What magnitude am I in? Because your answer at the end should maintain the same magnitude. For example, this one down here, we're going to round it to the first 1 significant digit, 1 digit. So obviously it's the 5. We look at the immediate neighbor, the neighbor is 4, it's less than 5, so 5 remains 5. So the number that we round it to would be 5,000, okay? 5,000 and not 5, because we had literally dropped it. By dropping those zeros, you had changed the magnitude, okay? Don't change the magnitude. And if you forget about it, you just don't remember, well, easiest way, because we all understand money, right? Put a $5 mark in front of it. You're starting off with a $5,000 magnitude. So your answer should end up in the $5,000 magnitude, not in the $5 magnitude like that. Okay. All right. So in this particular exercise, what we are looking at is determining, well, we've got to take that number. Now, keep in mind, we're going to see how this comes into play later on. You do a mathematical function to these numbers and other numbers, and you came up with this answer. Your calculator spits out 1.8374. But you know that your answer should not be more accurate than the least accurate number that you did the mathematical function with. So in this exercise, we're telling you, okay, the least accurate number that you used had 3 sig figs. So our answer should not have 3 sig figs, okay? More than 3 sig figs. So it would be incorrect to give 1.8374 as your final answer, because that is more accurate than it truly should be. So we find it tells rounding out the three sig figs. So starting from the far left, you count the three sig fig position, which happens to be the 3 here. Okay. So then you look at the neighbor, immediate neighbor, and determine from the rounding rules what you got to do with the 3. In this case, the neighbor is 7, which is greater than or equal to 5. Therefore, 3 gets kicked up to 4. At this point, notice the numbers 7, 4. They are after the decimal point. So you just drop them completely. If the numbers were before the decimal point, then you change those numbers to 0. Otherwise, you change the magnitude. Here, you're not changing the magnitude at all. You're still at the you're still in that magnitude of 1. You're somewhere between 1 and 2. Okay, you just become a little more accurate with respect to the numbers that you had to work with in the beginning. So the answer is 1.84. Okay, that shows you the correct number of sig figs. Here we have 7,162.32. They're asking you to round it, to truncate it, or truncate it to 3 sig fig position. Well, in this case, it is the 6. Okay, so we look at the neighbor again, which is the 2. So the 6 remains a 6. Now, here's the thing to remember. The 3 and the 2 after the decimal point totally remove. You get rid of it. You're not going to need it. The 2 before the decimal point gets converted to 0, because we are in the $7,000 range of magnitude. So your answer should be in the $7,000 range and not in the 700. Okay, totally different magnitude, 700 versus 7,000. All right, so let's do one more. Here, we've got to go through the 3 significant number position. Remember that the zeros, those zeros are leading zeros. And that question you might forget. I don't remember if that's significant or not, those zeros. So you ask those 2 questions. For these zeros, okay, for their zeros, is there an integer in front of these zeros? And the answer is no. Therefore, with respect to significant digits, they don't count, okay? They only count in maintaining the decimal point, the decimal position, in maintaining the position or the value, the magnitude of that number. Okay, we don't drop them because they're still significant. They're insignificant with respect to, they don't play a role in determining how many sig figs your answer should be. And that's the main difference here. Don't confuse the 2. Okay, as far as I really wish the term significant figures was an alternative term, but unfortunately, that's a term that's utilized because it gives an idea that those numbers aren't worth anything, the ones that are not playing a role in sig figs. All right, so we go to 3 sig fig position, like we've been doing. We look at the neighbor's 1. That means that the 1, 5, and 4 are truncated, removed completely, I should say. Okay, and your answer is 0.013. Okay, now you might ask, well, what happens if I do this for number 2? All right, you just say, what if I mistakenly convert the 3 to 0? So my answer is 7,160.300. Okay, what if I did that? What would be the problem of doing that? By taking the 3 and the 2 and converting those to 0 like we did with the 2. Okay. Okay, what given, and I mean the problem, given that the question asked to keep it to 3 sig figs. Okay, what would be the problem by doing that? Anybody know? By doing this, by converting the 3 and 2 to zeros. What have I done by making it 0.00? What have I done with respect to sig figs? Maybe that'll help. Okay, this one versus this one. How many sig figs does this have? 3, right? That's what the question asks for. How many sig figs does this answer have? 7160.00. Anybody know? Yes. Okay. You got one answer. It has exactly 6. That's correct. Well, Bombay. I think I pronounced your name right. Okay, that is correct. And so that's, you might be tempted to add zeros for those numbers after the decimal point, but in doing that, you have increased the number of sig figs, so that would be incorrect, okay? All right, let's take a look at this one, 254, I should say, 24,925. We find the 3 sig fig position, starting from left to right. We look at the neighbor's 2. 2 and the 5 are before the decimal point, where the decimal point will be, so they get converted to zeros. Keep track of your magnitude. We are at the 24,000 magnitude, okay? And so our answer is 24,900, not 249. Okay. All right, so the key points about rounding these numbers are finding, bring your number to the correct number of sig figs is, again, we're doing this because we did some type of mathematical function to obtain these numbers 1 through 4, but because those numbers have a certain number of sig figs, whatever we use to get to these values, we can't report it more accurate than those numbers, which in this case had 3 sig figs. Okay, so this was an exercise to take your answer and put it in the correct number of sig figs. Now, the one drawback that the book has, which I think I'm going to address it and have them change it a little bit with respect to the term sig fig. I mean, the term sig fig in itself, it gives connotations that the number is not worth anything, but it is. So, but we're going to continue with sig figs. But here's the deal. You can put this in long-term memory. When we multiply and divide, we have to count sig figs, okay? When we add and subtract, we're not counting sig figs. We are looking at decimal places, okay? Now, your question that you might be asked is if you're working the problem as well, give your answer in the correct number of sig figs, okay? That's what the question says at the end. Well, when you read that, you do 2 things. One, look at the mathematical function that you're doing. If I'm multiplying and dividing the problem, then yes, I think in terms of sig figs, and therefore my answer should have no more sig figs than the least number that I usually has, the least number of sig figs, okay? Or if I look at the problem and I'm adding and subtracting, I don't even think about sig figs. I think about decimal places. And we're going to have some examples of that here now, because in multiplying and dividing, you think sig figs. Adding and subtracting, you think about decimal places. And if you really give us some thought, we are doing the same thing in that our answer is no more accurate than the least accurate number that I utilized to do whatever I needed to do mathematically, okay? Now, don't mix and match the 2, okay? Don't think sig figs when you're adding and subtracting, okay? And don't think decimal places when you're multiplying and dividing. Totally separate. The ultimate goal is to give your answer in the correct number of sig figs, either be decimal places, governed by decimal places, or governed by significant figures. Let's take a look at this number here. We got 13.5478. Okay, so we had a measurement, right? Then we're going to subtract, but it can easily be plus by the number 11 0.20. Okay, now, who can tell me of those two numbers, which one is the least accurate? Okay, they're measurements, so there's a degree of uncertainty, but which of these two numbers is the least accurate? Okay. Yes, the 11.20, simply because, that's correct, guys, because I only have two decimal places compared to the 13.5478 that has four decimal places. So obviously, that measurement of 13.5478, it could have been a laser beam. You know, it's the only thing I can think of that gives us accuracy to the fourth decimal place. And the bottom one is maybe a tape measure or ruler to give us only on to the 100 place. Okay. And so what's going to govern your answer as far as presenting it will be the one with the two decimal places. Okay. I hope everybody sees that. Here we got four decimal, I'm gonna call them DP decimal places. And here we have two DP decimal places. So obviously this is the least accurate number, which by the way, the symbol pound means number. That's always been that. Now it means something else. All right. So we do the math, and this could be true if we were adding these two numbers. So it's either add or subtract. Okay. And so you do the complete math with all the decimal places. Okay. Now that's your math. Your answer is 2.3478, but we can't present it in that manner. Okay. We have to find where we're going to truncate it, and that's at the 4 because it's a two decimal place position. And then we do like we've been doing the rounding. We look at the immediate neighbor, and the immediate neighbor is 7, which means that 4 becomes 5. And so our answer is 2.35. And so with two decimal places, because that is the number, it is the least accurate number. See the subtle difference between this and adding and multiplying and dividing. Okay. Okay, so when the question says, give your answer to the correct number of sig figs, think about what you are doing mathematically. If you are doing adding and subtracting, then focus on decimal places. If you're multiplying and dividing, I cannot emphasize that, focus on sig figs. Okay. This slide here, just a reminder as far as where the decimal places are, you know, what they're worth, the 10 place, 100 place, etc. Fresh memory. Okay. With respect to multiplication and division, focus on that digit that has the least number of sig figs, because that's going to tell you how many sig figs your answer should have. So two things there. Let's take this. We got 3.546 times of 1.4 meters. Okay, now which number here has the least number of sig figs? The 3.546 or the 1.4? Okay. We've got the least number of sig figs there. Yeah, the 1.4, exactly. Okay. And so there are two sig figs there, SF. Notice I use DP for decimal places previously. So SF is two sig figs. So our answer should have no more than two sig figs. Now, don't do any truncation here, round it. Take the numbers you are given, all of them, do the mathematics, then at that point, do the rounding at the correct number of sig figs that you need to do, okay? I've seen in the past where the people have taken the 3.54 and convert that, put that in two sig. Don't do that, okay? Don't do that. Do the math, and then at the end, put in the correct number of sig figs. And so here we have the answer, the full answer of 4.9644. Okay. And we needed 2 sig fig positions, so that would be the 9. That is the 2 sig fig position. Okay. We look at the neighbor's greater than 5. Okay, so that 9 gets kicked up to 8, in this case 10. There's the 1. So our answer is 5.0. Okay, which has 2 sig figs, just like this one, 1.4. Okay. Second of all, when you multiply and divide, don't forget that we have to maintain the units. And so you might ask yourself the question, refresh your memory. We're multiplying, so m times m will give you m squared. Okay. And if you multiply m squared times m again, then you get m to the 3rd power. And if it's m next and then multiplied by m again, m to the 4th, m to the 5th, etc. Okay. Previously, if we were doing 1.5 centimeters and we added or subtracted, let's say 2.5 centimeters. All right, we can add these two numbers because their units are alike. And then if we're adding these are 10, 2, 3, 4.0 centimeters, okay, like units. Okay, so we can only add or subtract numbers that have like units. There's your algebra come into play. If this was in meters, one was 1.5 meters, we couldn't add 2.5 centimeters. We have to convert one or the other into like terms, okay? All right. Okay, so keep that in mind with respect to your units. All right. Focus on sig figs when it comes to multiplication and subtraction. Well, this brings us to scientific notation, okay? And this is just a shorthand method, a convenient method, as it says here, to express and to write very large numbers or very small numbers like you're given here. It's also a method that allows you to place a large number or a very small number into your calculator to do calculations, which we will be doing, okay? So you're going to have to be familiar with your calculator to be able to determine how to put your large number in or small number in there. And we're going to do some examples. All right. So the way we do this is as follows. All right. So we got this number here, 93 million miles, approximately the distance from the Earth. Okay. Now, the format for scientific notation is as follows. We have an integer all by itself from 1 through 8. In this case, we got 9. Then we have a decimal point, and then whatever numbers follow the decimal point as needed, depending on the sig figs that you have. Okay. And so what we do is we take the 93 million here, and we see where the decimal point would be, right? We go, in this case, this is a number much greater than 1, so keep that in mind. So where the decimal point will be, we go from right to left, and we count the number of decimal places. So we go, and then we continue to count until we hit the last, get close to the last integer, and we stop right in front of it. Okay. So for example, we got here 1, 2, 3, 4, 5, 6, 7. Okay. That means that I'm moving my decimal point 7 positions in from right to left, which tells me now I can write 9.3 times 10 to the 7th power. Another way to write this is to see this is another way of saying 9.3 times 10 times 10 times 10, etc. I'm going to let you do that, etc. to 7. In other words, taking 9.3 multiplied by 10 7 times. Okay, that's all you're doing there. All right, so notice that the exponent represents how many decimal places we moved, and it's a positive exponent. Being a positive exponent tells you that I got a number greater than 1. Okay, so you can see here that this exponent can go to infinity with respect to value. All right, from 0 to negative or positive infinity. We'll be dealing in negatives, but this is just an example of a large positive number. Okay, so that's the format. The point here is the standard scientific notation is an integer followed by the decimal point and then whatever numbers you have. Now, when you convert a number, large number, into scientific notation, the first thing you look at is to determine how many sig figs you have. Okay, so 93 million has 2 sig figs. So we have to write it with 2 sig figs in the same format, scientific notation. 9.3 is 2 sig figs. If we need to write that number 3 sig figs for whatever reason, then it becomes 9.30. If it's 4 sig figs, 9.300. See that? Because we're already in putting any number in scientific notation. If you ever run into a problem where it's kind of ambiguous, and you're not sure if you wrote that number in the correct sig figs, convert it to scientific notation, because there's no question there that you can put it in scientific notation, it will have the correct number of sig figs. Okay, so that's the format. So this, yes, 93 times 10 to the 6, yes, that is 93 million, but it's not in the correct format for scientific notation. Format again is an integer 1 through 9, decimal point, and then whatever follows after that. Okay. Right. So now it's for a very big number. Now for a very small number, we do the following. Same scenario, I should say, by as far as decimal point. Find where the decimal point is. In the previous example is a number much greater than 1. Here, there's a number less than 1. Okay, so it's a decimal number. So we find the decimal point, and we count, in this case, from left to right, the position, the decimal places, until we find the very first integer that we encounter, and then drop that integer right after it. Okay, drop that decimal point right after the first integer that you find, which is the 1 here. So we already know it's going to be a 1.7. Okay, so starting from the decimal point, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 10. So that is the exponent for our 10 to the 10th power. But it is a number less than 1, therefore it is a negative 10. And so it's 1.7 times 10 to the negative 10. And this is no different than writing it longhand by saying it's 1.7 divided by 10 times 10 times dividing by 10, okay, etc. You got 10 times, okay? And that's just another way of writing that. That's the longhand way I just wrote it there. So we got 1.7 times 10 to the negative 10 meters. Okay, so that's the way to write scientific notation in, excuse me, writing very small numbers in scientific notation. As we did with numbers greater than 1, we note the number of sig figs. We have 2 sig figs here, 2 sig figs. So our answer should have 2 sig figs, okay? 1.7 times 10 to the negative 10. All right, so here, they're asked, the problem here says, convert the following into scientific notation. All right, so systematic approach is I take everything. Oh, by the way, my background here is a list of chemicals that are common to a lot of the good smelling. Maybe you finding fruits like banana oil, wintergreen. If you're interested, I got it behind me. Just to show you all the chemicals you ingest when you're eating, say, wintergreen. All right. Okay, so here we got the problem. We're going to convert these numbers into scientific notation. Step number 1 is determine the number of sig figs, because your answer has to maintain the same number of sig figs. Okay. And so how many sig figs does the first number have? 548.005. Okay. How many sig figs? Anybody know? Got 6, exactly. 5 to 4 to 8, and then everybody's significant here. And so our answer should have 6 sig figs. Now we take the decimal point, and again we go for wherever the decimal point is a number greater than 1. Okay, so we're going to go from right to left until such time we find the last integer and we stop right in front of it. And so we go 1 and 2, so 2 decimal places. So that tells me times 10 to the second, positive second. Okay. And then we write 5.48005. We haven't lost the number of sig figs. It's still six sig figs, but now that number is in scientific notation, so it's 5.48005 times 10 to the second power. Okay, it's like taking that number and multiplying it twice by 10. All right, the next one, same example, similar example as the very first one. We find where the decimal point will be. We count the number of positions until we stopped at the right before the last integer, which in the case is the 6. And so we go 1, 2, 3, 4, 5, 6, and 7. Okay, so it's 10 to the 7th power. Plus, there's only 3 sig figs in that number. So our answer is 6.81 times 10 to the 7th power. Okay. Also numbers greater than 1, so therefore our exponents are all positive. Now, with respect to a number less than 1, that should tell you that it's going to be a negative exponent. Okay. So here's the decimal point. We go 1, 2, 3, and 4. That'd be -4. We have 3 sig figs, so that becomes 4.00 times 10 to the -4. All right, my pen's still not functioning. I got a tech support question out to Zoom, trying to figure out why it's not working. All right, let me clear it up and show the answers here. So those are the answers. Don't forget your units. The last one, 2000. Okay, same process. We got 1 sig fig, so we start here. We go 1, 2, and 3. So it's through the third power. All right. Now, let me ask you a question. Let's say you have the number 2000, and that's your answer. Okay. But you multiplied some numbers, and whatever reason, you know that the least number of sig figs to get that value 2000 was 2 sig figs. Okay, 2 sig figs to get me, and then when I did that on the calculator, I'm multiplying and dividing, I end up with the number 2000 for whatever reason. Okay. Now the question is, all right, how do I write 2000 with 2 sig figs? Right? I can't put a decimal point after the last 0, right? Because then it makes all those zeros significant. So what I do is I convert it to scientific notation, like we did here. But if I simply go 2.0 times 10 to the 3rd power, that is also 2000. Okay. But it's 2000 with 2 sig figs. I just simply add a decimal and a 0. And if I needed to write it with 3 sig figs, I just had another zero there, right? And you can go to infinity. If I need to write 2000 with 10 sig figs, I just add more zeros. Okay, in front, not the exponent. Okay. And you can see, convince yourself, if I take 2.00 multiplied by 10 3 times, guess what? I still get 2000. It's just in the scientific notation. If you end up with a number that you need to write it with the correct number of sig figs, sometimes the number can be written by itself, just like 2000. I can't write 2000 with 2 sig figs, okay? But if I convert it to scientific notation, automatically I can put it in any number of sig figs that I need. Now, how do I get this information into the calculator? All right. Well, there are most calculators is 1 or 3 functions. Okay. Now there's some old time calculators that on the top right, this is kind of diluted a little bit. Maybe I can use this one here. Yeah. The middle calculator, there's a button that has EE. That is the exponent function of getting a number into scientific notation. Okay. The calculator on Windows, which maybe if you're working on Mac, maybe it's very similar if you select the scientific calculator. But in Windows, for sure, my Windows shows that button as an EXP. Okay. Some of the newer calculators have this function here on the first calculator image that is labeled. If you see that, it says it's a times. Let me see if I can draw it a little better. It's a time symbol. Then it's 10 to the X. That's what that one shows. This button here shows a double E. Okay. And then the Windows calculator has the button EXP. Now, in all 3 cases here, the scientific notation function is a function up front on the calculator. Some calculators have the scientific notation as a secondary function. And so if that's the case, you may need to use the second button on your calculator to access that secondary button, which normally you'll see it here in this case in the middle. You'll see that function in a different color, like this one's in yellow. Okay, so check your calculator, check the manual. And if you're having trouble with it, shoot me an image of your calculator and we can work through it to make sure. So what you're going to learn is how to input these large numbers into your calculator so you can do calculations. All right. So if we are doing an actual input, let's say we want to input 2.39 times 10 to the 9th power, you would type in your calculator 2.39, okay? Then hit the button, the scientific notation button, be it this button or that button or that button. Now, a word about this button, the X 10 to the X. That is not the same as a button that says 10 to the X. That is not scientific notation. Okay, so be very careful. Check your calculator. Only, and this is for the newer ones that have this button right there. And they have an X, then 10 to the X. All right, so make sure you're pushing the right button, not the wrong button. So I would type in the 2.39. Then you type in the button for your calculator. And then at that point, you put in the exponent. Another button you should be familiar with on your calculator is the toggle button to go from positive to negative. For example, on the Windows calculator, there's a button right there is +/-. When you put any number in the calculator and you toggle that button, you'll see a plus symbol or a negative symbol, I should say, will show a plus. Some calculators might. Yeah, give you a plus or a negative symbol so you can make sure you're toggling is it a positive number or a negative number. Okay. And let me see some other calculators. you'll have to find like this button right here for this calculator. That's the toggle. It's tough to see on the one in the middle. Maybe, here it is right there. That's the toggle button for negative and positive. Okay, so you after you touch or hit the whatever of the three buttons, then you put your exponent. Okay. And it will put it into the format that your calculator understands. Keep in mind for all three calculators, unless you got a real fancy, calculator, most of the time, the inexpensive calculators puts it in the format for the calculator. Some calculators may put it in this format, which is the correct format for scientific notation, but other calculators may print it out as on the screen as say 2.39, then use the letter E and then followed by a 9. So that's the format for the calculator. That is not scientific notation. And so if you see that number like that, be aware that that E represents the times 10 and that 9 after the E is the exponent. So you need to convert that into the correct format and you're inputting an answer, okay? All right, we'll talk some examples about that here in a second. Okay, so let's try this number here. In fact, let me go back and actually input that number on the calculator for Windows. Let me pull up my Windows calculator and then I will share the Windows. Pull it up. Okay, and so here we're going to input the value 2.39 times 10. Come on, calculator. Pen, I should say. That's the number we're going to input. 2.39 times 10 to the 9th. That's not negative 9, 10 to the 9th. And so on the calculator, I would type in 2.39. Now, if this was a negative, I could toggle it here. See that toggle button? By toggling, I can make that a negative or positive. That's positive, that's negative, but it's a positive number, so it's 2.39. Then in the case of the Windows, I would hit the EXP button, or in your case, maybe the EE button or the X10 to the X power button. So when I click that, Windows puts in that format. Okay, notice now it's got the E that says for the Windows calculator, that's the format. Okay, now I can type in the exponent and I just simply type in the exponent. And so I got 2.39 E plus 9, okay, which is the format for the calculator. All right, now if that was a negative 9, I'd simply hit the toggle button. Notice that I can toggle back and forth. So it's either a positive exponent or a negative exponent. Now that's the number 2.39 times 10 to the 9. Now you do the mathematics of whatever you got to do with it. No different. It's just a number. Now you can multiply, divide, subtract it, add whatever you want to do. Okay. All right. So let's go back to, obviously you need your scientific calculator. Now let's plug in this number here. Okay. And so if you want to write down the problem, because once I share my calculator, you probably won't see it. So it's 2.84 times 10 to the 23rd divided by 7.29 times 10 to the 12th. Now, here's the mathematical function. So the first thing you got to do when you look at this is identify how many sig figs I have. So how many sig figs does my numerator have? (2.89 times 10 to the 23rd). How many sig figs does that number have? Ready now? 2.84. How many sig figs is that? 2.84. Forget the times 10 and 23rd. How many? 3, exactly, Erica, you got it. How about 7.24? How many sig figs there? Exactly 3. Therefore, I'm taking 3 sig figs, dividing by 3 sig figs. Our answer should have 3 sig figs. Okay? See how that works? Now, I'm dividing, so I'm worried. I focus on sig figs. If this was a subtraction or an addition, I would focus on decimal places. Okay? All right, so now let's take that number and I'll share my calculator again, and we're gonna input it. So let me clear my calculator, and we're gonna take 2.84 times 10 to the 23rd. So we got 2.84 exponent, okay, 23. Okay, that's my numerator. And I'm going to divide by 7.24 exponent 12. So I got this big humongous number. Big humongous number. And the way some calculators do, they give your answer in long form. Windows does that. If you need to go kick it back into scientific notation format, there's a button, at least in Windows, and there should be one in your calculator, that you can toggle back and forth from writing that number longhand or scientific notation. If I click that, okay, that button, I get scientific notation, okay? And I get this big number here. Okay, now let's go back. That's my answer. Now, would you report that answer as that? And the answer to that is no. Okay, but let me put that in here. Okay, 2 things. The E plus 10 is in the format of the calculator, but it's not in scientific notation. So first thing I would do is I would get rid of the E, and you can leave the plus if you want, and that would be 10, and then the times 10, and then that symbol, I think we call it caret, which is shift 6. That is the exponent. Okay, so that is taking 3.92265 blah 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 times 10 to the 10 power. That plus symbol, it's understood to be plus. Your prerogative to put it there. Definitely was negative. Yes, no prerogative there. It was a negative value. Keep the negative exponent. Positive, you can take it off. All right, so now we decided that we have to have an answer with 3 sig figs, right? And so we go to the 3 sig fig position. Here's 3, that's 1, 2, and 3. Okay. So the first 2 is the 3 sig fig position. So we're going to determine, do we need to keep the 2 at 2 or kick it up to 3? We do that by looking at the neighbor. The neighbor is another 2, which is less than 5. Therefore, the 2 remains as 2. And now we can get rid of all those other digits. Because even though you might say that's very accurate, but you didn't measure it with that accuracy. Okay. It wasn't measured with that accuracy, so you cannot be more accurate than the least accurate digit. And here, both of them happen to be 3 sig figs. So your answer would be in 3 sig fig formats. So that should be your answer. And oh, there it is right there. Okay, same answer we got, except with the PowerPoints, I can put it into scientific notation. Now, you might be tempted to do 3.9 2, and then E, and then, plus 10. Well, for this calculator, yeah, that is correct. That would be correct, but that is not scientific notation, okay? So you gotta convert that E into times 10 and then write it as given there, okay? That would be incorrect. All right, here. Sometimes you might be you want to write this number. A number shows as it depends on your calculator. It may show it as 1.32456, and then like a superscript 8. And that's your calculator trying to tell you that's the scientific notation. So what's really telling you is this, that number should be 1.234. I don't know how many digits you're gonna bring it to. You need to bring it in, but let's assume you gotta use all of them. So you're gonna convert that to times 10 to the 8, okay? That's the scientific notation, what I just wrote. This means you take this number and multiply it by itself 8 times, which is a totally different number. And it's like saying, 2 to the 4th power. That's like 2 times 2 times 2 times 2. So make sure you convert it to the correct format. All right, so as I mentioned, also that depends on the calculator. That sometimes that format or these functions are secondary functions. So you might need to put it into a different mode to do that function. So take a look at your calculator. You have any questions? Feel free to shoot me an email and then we can go through it. All right. And this brings us to the last part, which is percent, which I'm not telling you something you probably don't already know, because you keep track of your grades, right? You have a total number of points for this class, total number of points, but you earn a certain number of points for the not the labs, but the homework, certain number of points for the activities, and a certain number of points for the exams. But overall, you end up with percent. You have a percentage. So the percentage by definition is what is called the part divided by the whole times 100. Okay, very fairly straightforward. For example, if you had a ring that has a total weight of 239.45 grams, and underwent analysis for gold, it turns out that it has 198.38 grams of pure gold. And it says, what is the percentage of gold in this ring? Well, it'd be simply 198.38 divided by 239.45. Okay, keeping track of your sig figs, always doing that. Noticing that the 198.35 has 5 sig figs, the 239.45 has 5 sig figs. Okay, so your answer should have 5 sig figs. Okay, and so we go from your answer 1, 2, 3, 4, 5. Go to the 5 sig fig position, which is the 8. We look at the neighbor, okay, which is a 1, so that 8 remains an 8. And so that is the answer with the correct number of sig figs, which are driven by 1, the mathematics, which in this case we divide it, so that sig figs are a factor here. Okay, your answer should be no more accurate than the least accurate number that you utilize in your calculations. All right, so that, ladies and gentlemen, ends up chapter 2. Okay, and what I want to do, unless there's any quick questions here, by the time I got left over, I want to show you a couple of slides, because this is related to the next chapter, where we're actually going to be doing conversions of English to metric units, metric to English units, okay? Using a particular technique. I think your variety of names for the technique, it's factor label for our book, our textbook. I call it simply, hey, keep track of your units, okay? You set this problem up properly and you keep track of your units, I guarantee you 99% that you have set that problem up correctly. I can't give you 100%, and the reason I can't do that is because I don't control the calculator, you do. So, there's an error in the problem. It's because maybe a wrong number got pushed. But if you set it up properly with the technique that we're talking about, you should not have any problem whatsoever. Okay. Now, what I want to share with you, kind of a brief, crazy example of how this technique is utilized to convert from one unit to another, which on the surface has no connection, but using conversion factors, they do. So, but let me get into the metric real quick, because that sometimes is a challenge. Okay. Now, when we talk about units here, we talked about mass, volume, and length. These are measurements. The units for mass generally is G, okay, for grams. That's the most common unit. Volume is capital L for liters, and length is M for meters, okay? The connection in metric units, and if you're not familiar with metric units, this kind of puts it all in a nutshell. A lot of advantages of using the metric units, and I can go from one unit to the other. Now, prefixes. All three, mass, volume, and length, share the same prefixes. A lot of these prefixes. For example, 1 kg, which is kilogram, is equal to 1,000 units. Okay, 1,000 grams. Okay, 1 kilogram is equal to 1,000. Guess what? 1 kiloliter is also equal to 1,000 liters. Okay, and 1 kilometer or kilometer also equal to 1,000 meters. Now, the next unit is the D, which is the prefix deci. Now, one way to remember this is straightforward, I think. How many years in a decade? Can anybody tell me that? How many years in one decade? Here, let me give you a hint. Oh, no, don't need a hint. 10, very good. Look at that. The hint I was going to give you was right there. Okay. There are 10 decigrams in 1 gram. There are 10 deciliters in 1 liter, and there are 10 decimeters in 1 meter. Okay. Now, how many years in 1 century? Here's my hint. 100, exactly. So there is 100 centigrams in 1 gram, 100 centiliters in 1 liter, and 100 centimeters in 1 meter. Now, you may or may not know this, but how many years in the millennium? I'm sure you all heard of the Millennium Falcon. No. Let me give you a hint. 1,000, exactly. There are 1,000 years in 1 millennium. It's a little bit of a tongue twister. Therefore, in 1 gram, guess what? There are 1,000 milligrams. And in 1 liter, there are 1,000 milliliters. And there are 1,000 millimeters in 1 meter. The only one that you may not know is this symbol here, looks like a U with a little lip in front of it. That is called a micro. The unit is micro. And so there are 1 million micrograms in 1 gram. Okay. In fact, if you take vitamins, if you look at your units, you'll see units like 5,000 units. 5,000 units, let's say, of vitamin E. I know this because I take vitamin E. Says 5,000 units. What that represents, don't quote me on this, but I think it's 125 mcg, which is micrograms, okay? 125 micrograms, FYI. All right, so there's 1 million micrograms in a gram, and 1 million, guess what? Microliters in a liter, and 1 million micrometers in 1 meter. Now, every one of these that I present here in the table are conversion factors, okay? And being conversion factors, they can be written in a ratio. Okay, so if we take the first one here, and it can be any one of these, I can write them as 1 kilogram over 1,000 grams, or I can write them as 1,000 grams over 1 kilogram. Okay. Now, I'd be tempted to want to switch, convert that that 1,000 into a number less than 1 when you do a conversion. My recommendation is don't do that. Okay. Or also to, in this, you might be tempted to do this scenario where you got A, B is equal to C over D. And, that may be good, maybe the first time where you know A, B, and C, and you're looking for D, three of these 4 variables, and that's one. But my recommendation is to stay away from this system, okay, at this point. Because you're going to be doing a lot of conversions, and if you're not really keeping track of everything, you get to the third one by using this ratio system over here, it's going to throw you out in a big loop. So my recommendation is stick with this method. It will help you out, because we're going to use this method when we deal with chemical reactions. Okay. All right. So which factor we utilize here. And so you got 1, 2, 3, 4, 5 ratios for mass, 5 for volume, 5 for length. Each one that can be written in 1 or 2 ways. You got 5, 10, 50, you got 30 ratios here, just here, that you could set up, all right? Now, yes, you can combine some of these. We'll talk about that, but for right now, my recommendation is just keep them separated until you're comfortable with them. If you're comfortable with going directly from centiliters to liters, then by all means, I'm not going to stop you, okay? But if you're not sure about it, my recommendation is just follow the steps, systematic approach, and then at that point, when you get comfortable with the system, you can create your own shortcuts. To me, I equate that to riding a bike. The first time you rode a bike, I'm sure you fell a few times until finally you got up and you did it on your own and had your own little technique on how to ride that bike. So here's this technique we're going to utilize, this factor label. Okay. Now, the question is, I need to convert how many micrograms are in 0.125 kilograms. Okay. Now, normally I would start off in my future example. This is a PDF file, but the examples we're going to do, I always start off with writing down what I am given, which I'm given 0.125 kilograms. And then I write down the units that I need to get to. And then I know that I have a factor that I'm going to put here, the very first factor. And I also know that that factor I utilized, I got to put kilograms in the bottom. Why? Because I'm trying to get rid of kilograms and get me into some other unit. And so I know that there are 1,000 grams in 1 kilogram. So that's my first factor, okay? Which, if I stop the math right here, I'm only in units of grams. I'm not where I need to be in kilograms. So obviously, I need one more factor, which tells me also that I gotta have a factor that I'm gonna have grams in the denominator. Why? Because I want grams to cancel. Okay, and I know that from my conversion factors up there that there are 1 million micrograms in 1 gram. And so keeping track of my units and focusing on those first tells me, okay, I got the problem set up properly. Okay. Second of all, after I'm done, I look at the sig figs because I can't forget those. I got 3 sig figs here. Okay. These conversion factors are exact numbers. Exact. And therefore do not play a role in sig figs. They're exact numbers. So my answer must have 3 sig figs. And that's how I set it up. And now it's a matter of you plugging in into the calculator to give you 125 million micrograms in 0.125 kilograms. Okay. And you don't have to write it in scientific notation unless the problem asks you to write it in scientific notation. You can leave it out there because it's still displaying in longhand the correct number of sig figs. So either one will be correct, either scientific notation or written in this manner, unless the question says to actually put your answer in scientific notation. Then you need to convert that to scientific notation. Okay. There are these conversion factors that we give to you, which is 1 inch. And this is the ones that get us from the English to the metric. So 1 inch is equal to 2.54, and 1 pound is 454 grams, and 1 quart is equal to 946. Now, the thing sometimes is confusing is this. By convention, this conversion factor is exact. Very first one. And therefore would not play a factor in sig figs. However, the other two are measurements. And being measurements, they could be a factor. So I got 3 sig figs, 3 sig figs. And these factors could be a factor in your final answer. Okay. These 6 could be written in these 3 ratios here. And remember, that's true for any ratio, anything, like 50 miles per hour or $50 per hour, $1 over $50, so on and so forth. Some other examples. Okay, remember your algebra review. We're going to do some very basic algebra. You got a to the second power, which is simply just a times a. Okay, notice all the a's, so I end up with the a as my answer. So very basic algebra. Can only add and subtract like units, right? Okay. Whereas the divide and subtract, we don't really care about the units because we end up with units. Remember the grams over millimeters density, right? Totally different units, but they go along with the answer. 1.0 grams per milliliter, the density of water. Okay. Okay, well, which brings me to, and I think I have just the right time. I use this example. It's an extreme example. I used it when I was teaching at Carrington College, and these were my dental hygiene students. So I created this dimension. They call it in their book. It was called dimensional analysis. Factor label method. They're all the same. Contracting units. Okay? So what I did, I created this hypothetical question and these conversion factors. And this is what I'm telling you, that I can go from A to B if I have conversion factors. So I gave the conversion factor that 1 dental hygiene is equal to 6 grapes, 3.5 grapes is equal to an orange, 1 orange is equal to 6 toothbrushes, and 3 toothbrushes is equal to 1 banana. 1 banana, excuse my English, but 1 banana. All right. Given those conversion factors, and this is analogous to a chemical reaction that you're going to be using down the road, and you're going to like, whoa, I want to go from sodium carbonate to carbon dioxide. And, I got apples and oranges here. but we can if we got conversion factors. Okay, given the following conversion factors, how many DH students equal 4.5 bananas? All right, so let's set it up. So here's the problem. Here's a conversion factor. Write down what we're given, 4.5 bananas, okay? And we throw in our first conversion factor with bananas in the denominator because I want to get rid of bananas and get me into another unit. In this case, based on the conversion factors, I have the relationship between the toothbrush and bananas. Okay. Well, that's good. And mathematically, bananas cancel out, leaving me toothbrushes, but it's not where I need to be unit-wise, because unit-wise, I should actually write it way down here. I need to know how many DH students, okay? So that's and I write that down because that's my map. I know where I'm at, and I need something to keep me on track on my map and knowing which direction I'm going. Okay, so the max conversion factor is 1 orange is equal to 6 toothbrushes, because again, don't do the math yet, just set that up. My units are all canceling out, leaving me with units of orange at this point in the calculation. Okay, but I'm not where I need to be, so I need one more factor to get rid of orange, and I know there's 3.5 grapes per orange. Okay, keeping track again of my units. Okay. At this point, I'm in the units of grape, which is not where I want to be. So finally, I have one conversion factor that connects DH students with grapes. So checking my units all along, making sure that things cancel out, and lo and behold, unit-wise, I'm where I should be. Okay. So now the mathematics is up to you. You plug in the numbers in your calculator, and you should end up with 1.3 dental hygiene students is equal to 4.5 bananas. So see how crazy that is unit-wise? But the point being is I set that up properly with the right correction factors. I didn't change my numbers. I didn't change my 3.5 grapes over oranges, 1/6. I kept those numbers there as I needed. Okay. The other question I get a lot from students is your calculator. It says, what does it make a difference if I just multiply all of the denominator and all the numerators, and then at the end, do what I do here? No, it really doesn't. Okay. Or if I type in 1.45 and then I multiply by 3 and then hit the divide button by 6, multiply button by 3.5, divide by 6, would I get the same answer? And my answer is this: it depends on your calculator. And my best thing to do is to do it both ways, meaning this way. Plug in 4.5 times 3, and then hit the divide by 6, and then hit the multiply by 3.5, and then divide by 6, and see if you come up with that number, or more likely this number. Okay. Then do it this way: take the 4.5 times 3, and then hit the equal. Then hit the divide by 6, then hit the equal. Multiply by 3.5, hit the equal. Divide by 6, hit the equal. And hopefully you get the same answer. So what that tells you is that a calculator understands the format of mathematics and gives you the right answer. But there's some calculators that don't understand that, and you got to hit the equal after each mathematical function. So check out your calculator, make sure that it's working properly, or you're familiar how it works. Okay. All right. So that ends that extreme example, and we will begin with chapter 3, which is basically going through a lot of conversion factors using the technique. Fairly short, and it shouldn't take too long.